work file contains facts you must use correctly should you process it on your own laptop or send it to cloud artificial intelligence. We gave the same labeled memo to local Qwen and ChatGPT, ran 18 controlled task executions, and checked not only the answers, but whether the evidence actually supported them. Welcome to TechExplorers. We test artificial intelligence, automation, and future technology so you can decide what to use, what to buy, and what to trust without hype. The objective is not to declare one permanent winner. It is to answer 4 practical questions. First, can each system extract the correct facts? Second, can it follow strict formatting and citation instructions? Third, how long did each route take in this setup? And fourth, where did the document travel during processing? By the end, you will have a simple framework for choosing local, cloud, or a hybrid workflow for your own files. Local artificial intelligence means the model runs on hardware you control. In this test, and 3, 8B ran through Olama on the laptop and requests used the local address 127.0.0.1. Cloud artificial intelligence means the request is processed by an external service. For this test, the same synthetic memo was submitted through signed out ChatGPT web, where the auto selector resolved to GPT 5.6. These are different delivery paths, so the comparison must be interpreted carefully. We created a synthetic business memo called Project Aruna. Synthetic means it was made for this experiment and contained no real confidential data. The memo had 12 approved facts labeled F, with 6 dated actions labeled A, and 2 rejected proposals labeled D. Those labels matter. They let us check whether an artificial intelligence merely produced a plausible answer or pointed to the exact evidence requested. Here is the complete procedure. Step 1. One memo, 1 answer key, and the same 3 prompts. Step 2. Run a summary task, a strict JSON extraction task, and a question and citation task. Step 3. Run every task 3 fresh times on local Qwen and 3 fresh times on ChatGPT. 3 tasks multiplied by 3 runs multiplied by 2 systems gives 18 task executions. 4. The outputs against the answer key for correct values, correct structure, and exact evidence labels. 5. Record elapsed time and document the data path. We did not disable the network. This is not an offline test. The first prompt asked for exactly 5 bullet points, fewer than 120 words, post label in every bullet, and no rejected proposals. Both systems passed those visible format checks in all 3 runs. But that was not the whole story. Qwen introduced connective or interpretive wording that was not directly supported by the memo. One cloud run used future tense wording for a launch the memo recorded as completed. The lesson is simple. Clean formatting can still hide a fidelity problem. A business summary must be checked against its source, even when it looks polished. The second prompt required only a 6-field JSON object, project name, approved budget, pilot city, launch date, primary risk and owner role. Both systems returned the exact expected JSON in all 3 runs. The recorded median was 818 seconds for local Qwen and 494 seconds for the ChatGPT web route. That means local Qwen recorded lower elapsed time for this task on this laptop. It does not mean every local model is faster than every cloud model. The third prompt asked 5 factual questions. Every answer had to be on 1 line and include exactly 1 supporting label. Both systems returned all 5 requested values correctly in all 3 runs. ChatGPT also followed the exact format and citation requirements in all 3 runs. Then followed the exact 5-line format in 2 of 3 runs, but missed the required A06 launch action citation in all 3 formatted responses. Here is the difference in plain English. 06 identified the Chief Technology Officer as the owner role. 06 recorded the action showing that the Chief Technology Officer officially launched Project Aruna on 15th March 2024. Qwen gave the right role, but pointed to the owner fact instead of the requested launch action record. That distinction matters in audits, research, and compliance work. Correct value is not enough when someone must trace the answer to the precise supporting event. On the citation task, medians were 328 seconds for local Qwen and 064 seconds for ChatGPT web. On the summary task, they were 368 seconds locally and approximately 972 seconds through the cloud route. Local recorded lower elapsed times here, but one route was a local API and the other was browser-based cloud interaction. Treat these as measurements of this setup, not a universal model ranking. Local requests went to 127.0.0.1 through Olama. The cloud test sent the synthetic memo to ChatGPT web. That difference can matter when deciding what content may leave a device. But local does not automatically mean secure. Device access, model configuration, logs and network exposure still need review. We also did not perform a network disabled run, so we cannot claim that this workflow was verified offline. Use a local workflow when suitable hardware and a verified local configuration meet the task, and the source file should remain on the device. Use a cloud workflow when you accept the service's data path and need the capability or convenience it provides. Consider a hybrid workflow when sensitive source material can stay local while only sanitized, non-sensitive context is sent elsewhere. Whichever path you choose, find an answer key or review rule for important work. Check the value, the format, and the evidence, not just whether the response sounds confident. This was one synthetic memo, 3 tasks, and 3 fresh runs per system on one date. It cannot rank every model or computer, and it did not test offline behavior. The practical result is that local Qwen was quicker in this setup, while ChatGPT followed the strict citation requirement more consistently. Neither result removes the need for human verification. Like this video, subscribe to TechExplorers and comment with the next file type we should test: spreadsheets, meeting notes, or research papers. Next, we will measure whether an artificial intelligence PC and its NPU change this same local workload.